Hello everyone, Dr. West here. So welcome to our final set of lectures for brain and behavior. The first couple are going to be from chapter 13, and then we are going to jump back and talk about some stuff from chapter 6. Let me sort of talk you through my rationale for why I organized it this way, and hopefully it will make a little more sense as we go through it. So what we're going to do here in chapter 13 is we're going to start a discussion about biological rhythms, and we're going to talk specifically about sleep, and that's one of your main biological rhythms that you experience hopefully on a daily basis. If not, your body is probably begging you for it and you're just denying it on a daily basis. But the other reason why I like to talk about sleep is because another sort of attribute about it is that it is an altered state of consciousness. So some of the themes that we've been talking about as we've been going throughout this semester is that you have different levels of consciousness. Now, hopefully, when you need it, your nervous system can activate you to the appropriate level of consciousness. So, for example, when you're studying or when you're taking a test, you need to be a little bit more kind of aware and focused. Your body can elevate you to that level of awareness and focus, and you can be a little more alert and activated. Now, hopefully you don't go too far, right? We talked about some strategies for anxiety if you get a little too overactivated. Hopefully when it is time for you to go to sleep, you can get relaxed that way. Hopefully when you're just sitting on the couch and chilling, if you ever get to do such a thing, you can just kind of relax and be in a lower state of arousal. But sleep is an altered state of consciousness. When you are sleeping, you are not in the same level of consciousness as you are when you are awake. Now, it doesn't mean you're completely unaware, like you might be, for example, when you're put out during surgery, for example, right? Or when you're in a coma or something like that. Hopefully you're never in a coma, but somebody could awaken you from sleep, but it would take a little bit of work, right? They might have to say your name very loudly. They might even have to kind of shake you gently to get you to wake up from sleep because it is an altered state of consciousness. And then I'm going to use that theme to tie it back in to the stuff we're going to talk about in chapter 6, which is using or misusing drugs. We're going to talk about how most drugs are psychoactive substances, which then purposefully serve to change your state of consciousness. Sometimes we use them on purpose to change our state of consciousness, and then other times that's just sort of a side effect of a medication that we are already taking for something else, for example. Again, a simple example I like to use with everybody that is real for me is if I ever have to take an allergy medication, particularly Benadryl. Again, I'm using it to stop my allergies, right? So I'm using it to stop the fact that like my nose is running and my eyes are watering and all that stuff. But it also has this convenient side effect of making me feel very, very drowsy and very sleepy, and so it alters my level of consciousness. And I only half joke when I say this that it will make me sleep for like 2 days straight. So again, that's the idea that we're going to sort of be kind of threading through these last couple lectures, is the idea of altered states of consciousness, both natural in the case of sleep, and then unnatural in the case of using drugs, again, whether they be legal or illegal. So let's first start off, though, discussing this idea of a biological rhythm. So we know that you have within your body some inherent timing mechanisms that control or at least initiate certain biological processes. Sleep is going to be an obvious one. That's why we're going to talk about that. But you have some others. You have some things that are innate within you that control various other, for example, hormonal processes, particularly if you're a biological female who still has a menstrual cycle. There is some inherent timing to that is based on control within your body. Your body changes temperature throughout the day. Your body changes a variety of things. And we're not the only animals that have this, right? There are other animals that undergo other biological rhythms as well. There are some animals that even do very large behaviors based on their biological rhythms. For example, there are some animals that migrate. There's some animals that hibernate. So there's a lot of different kinds of biological rhythms. And all of these various kinds of biological rhythms are typically linked to a cycle of days or seasons and are somehow influenced by that And those cycles of days and seasons are thus then produced by the Earth's rotation around the sun and then the Earth's rotation around its own axis. So as you can imagine, animals that might live further away from the equator, so more towards either the North Pole or the South Pole, are going to be a lot more affected by seasonal changes than animals that might live closer to the equator. And I've actually experienced this firsthand just because the amount of daylight, for example, is significantly different if you live further north towards the North Pole or further south towards the South Pole than if you do more towards the equator. So for 1 year of my life, I lived up in Maine, and I taught up there. And I can tell you, first of all, it's very far north. It's even farther north in some parts of Canada. Most people don't realize just how far north it is in some parts of Maine, especially where I was. And it's very weird. So, for example, in the summer, which I think the summer was actually weirder than the winter. I think I was a little more prepared for the winter because in the winter, it would still get daylight around 7:38 in the morning, which is not too strange, I guess, but it would be dark by like 3:30 in the afternoon. And I mean like nighttime dark by 3:30 in the afternoon. And again, people had sort of warned me about that. And that part I was like, I didn't like it, but I was like, okay, I guess I'm okay with that. It just feels weird. But the summertime was weird, going the opposite direction when you have more daylight, more sunlight. So the sun wouldn't set, like it wouldn't even be dark until like 10 o'clock at night. I mean, it would still be like daylight outside till like 10 o'clock at night. And I just remember it was like the second week I was there, I was going to work, I'd gotten up in the morning and I'd woken up in a panic because my alarm hadn't gone off, and I was like, oh my God, I'm so late for work. So I jump out of bed and I'm like running around trying to get ready, and I like grab my phone to see what time it is, to see how much time I had left before I had to be at work, or to see how late I already was, and it was 4:30 in the morning, right? That's how light it was. It was already as if it was like 10 o'clock in the morning, daylight at 4:30 in the morning. It's just crazy, the difference in light. Again, just because of where we live. We were so far north. So again, it's not like the cycle of the Earth, moving around its own axis or moving around the sun forces your rhythm, right? But it interacts and it influences your internal biology. And then your internal biology influences your own rhythm. So our behavior is actually governed by our own cycles. So again, just to sort of review again, the sun is the center of the solar system. The Earth itself rotates around the sun, but then the Earth also rotates around its own axis. And that results in having not only day and night on about a 24-hour pattern, but also different seasons. So for example, if you're in the northern hemisphere, like we are here in the United States, this time of year it's summer, so it's usually going to be warmer weather, more sunlight. If towards like December, at the end of the fall semester, it will be colder, less sunlight during the day, that sort of thing. But again, it's not the actual sunlight, it's not the actual rotation, it's actually a combination of how that affects the biology that's going on within us. And the reason we know that is because there are some rhythms that happen even if we aren't exposed to daylight, for example, right? So if we take away all the external cues, the behavior doesn't go away. The behavior is still there. So we know that there must be something within us, something that is controlling that behavior within us. So that's why we called this a biological clock, right? And we said that all neural systems, right, have something within them that help us to keep some sort of biological time, if you will. It's what allows us as animals to anticipate events before they happen. So for example, I was talking earlier about some animals migrate. Birds are one of those kinds of animals that do that. Well, they don't wait until it gets cold to go, oh, it must be getting to be winter, guess we should migrate, right? They've got some sort of biological clock within them that helps them to anticipate, okay, it's about that time, I guess we should go ahead and migrate. Sort of like you do, right? Like it doesn't actually have to be dark yet. You might start to feel sleepy one day, right? So again, you've got a built-in clock within you. So again, if you were to remove yourself from all sorts of cues, right? So if you were to go somewhere where there weren't any windows, so you couldn't see if it was light or dark outside, if you removed yourself from all clocks or all ability to see actually what time it was, and you let yourself have the ability to go to sleep when you wanted and wake up when you wanted, you would function still approximately on about a 24-hour schedule. Because again, it's not based just on the light and the dark. There is something within you that is biological that keeps you on a rhythm. And we call that a circadian rhythm. Now let's talk about this word circadian here. Circa means about, and dia or dian means a day. So these are rhythms that happen approximately every 24 hours, and your sleep cycle is one of them. Now, not all biological rhythms are circadian. Some of them happen other times. For example, the migratory patterns that we see are circannual, right? Circa, again, meaning about, annual meaning year. So these happen approximately yearly. There's some that occur ultradian, which means more than, less than, more than, I was right the first time, a day, right? So people tend to eat more than once a day. Infradian, right? Again, it takes more than one day, right? People don't have a full menstrual cycle in one day, right? That's what they mean by more than one day here. An eating cycle takes less than one day. So again, it doesn't take you 24 hours to have one eating cycle. Usually one eating cycle takes about 10 to 30 minutes to actually eat, and then an hour or two to digest, right? That's what they mean by less than a day. So again, there's different rhythms that happen in different amounts of time, but what we're going to talk about for sleep, right, is what we call a circadian rhythm, because it takes about 24 hours. But most things that happen within you, so most of your physiological, biochemical, behavioral processes show some kind of rhythm. And a lot of them are circadian, which means a lot of them do happen on that approximately 24-hour rhythm. So your body temperature, a lot of your other hormonal releases are about 24 hours. And a lot of them are also what we call free running rhythms, which means that if we left your body alone, if we didn't give it external cues, so that thing I was talking about before, where if I could take you somewhere where there weren't any windows or whatever, where you could see outside and see the light in the dark, if I took away clocks and stuff, if I took away all those external clues, your body would still keep up with that internal rhythm. Right? Now, it might adjust it a little bit, and what we found is that most humans will average a little bit more than the 24 hours for their sleep. It'll be somewhere actually around 25 to 27, but it's really close to 24 hours. And another thing that we know, though, is that it's not that the cues aren't important. They absolutely are. So it's sort of this balance between what naturally happens between our free running rhythms within us, so our natural cues, our natural biology, our natural hormones, our natural neurotransmitter levels, and all that stuff that's naturally happening, plus the things that are happening within the environment, the cues that we're getting from the environment. Right? So again, some things like clocks, for example, your cell phone that's giving you the time of day, for example. A huge one actually for us as far as sleep goes is the amount of sunlight, right? Being able to actually see light. And we call those fancy things. All of these cues, we give them a very fancy name called a Zeitgeber, depending on how well you can pronounce German, which for me is not good at all. Right? But nonetheless, all of those things count as a Zeitgeber. And basically what we know is that light is the most potent for resetting your sleep cycle. Unfortunately, your body is reset by both real light, meaning like sunlight, as well as artificial light. So brainstorm for just a minute about some places where you might be exposed to artificial light. What'd you come up with? How many of you came up with like our lights in our house or something like that? Right? Like the lights we have that we can just turn on at night so we don't have to go to bed when the sun comes down. That's a good one. A lot that people don't think of, though, would be things like our technology, like our screens, our computers, our cell phones. How many of you sleep with a cell phone next to your bed? I bet that's most of you. How many of you have it to where it will light up in the middle of the night? Right? Believe it or not, that's actually enough light to go through your eyelids and still actually cause some trouble as far as sending a cue to your body that there is light around. So let's talk about why that can be an issue. Again, if light is going to be the cue that's going to reset your rhythm, let's actually talk about why that works. Because again, the point of this class is to talk about the underlying biology here. So again, specifically for the clock of sleep rhythms, we need to talk about a part of the brain called the suprachiasmatic nucleus, or the SCN. It is the main pacemaker for most of the circadian rhythms, but particularly for the one for sleep. And it's located just above the optic chiasm underneath the brain here. So the suprachiasmatic nucleus is right here in the brain. It's called the master clock sometimes, and it is approached via the retinohypothalamic pathway. So retino means it's going to come from the retina, and it is going to go to the hypothalamus. So retinohypothalamic pathway. So as you can see in the definition here, it is a neural route from a subset of cone receptors in the retina to the suprachiasmatic nucleus of the hypothalamus. That's why we name pathways the way we do. Remember, the first part is where it starts, the last part is where it ends. We may have some words in the middle, that just means somewhere it went in the middle. That's how you can always tell a pathway is the first part of the word is where it starts, second part of the word, or at least the last part of the word, is where it ends. Now, back when we were talking about parts of the eye, I told you a little bit of a mistruth. Right? I said that all of the information from the retina, so all those rods and cones, eventually sent their information to retinal ganglion cells, and the retinal ganglion cells sent their information to the occipital lobe of the back part of the cortex, right? That very back part lobe would be processed for vision. Technically, that's true. I mean, yes, the retinal ganglion cells did do that, but there is a subset of cone receptors that aren't detecting color and they aren't detecting clear vision. They're specifically responding to light and then following this separate pathway that's sending that light information to a different part of the brain. So it's not going to the back of the eye. Okay? It's going to this part of the hypothalamus, again, specifically the suprachiasmatic nucleus. And this is what allows light to entrain the rhythmic activity of the suprachiasmatic nucleus. Now, entrain, again, just a fancy word for basically reset or activate the rhythmic activity of the suprachiasmatic nucleus. So this is what allows the biological clock within you to basically reset itself, to be on a rhythmic basis, because the day and the night per the rotation of the earth, right, is going to be rhythmic. Right? Theoretically, your eyes should be getting light on an approximately rhythmic basis like that. And these cones send that information. This is why we think there's been such an increase in change in quality of sleep, because people have been giving themselves too much artificial light, particularly with the use of technologies and that certain kinds of light that come from screens, from computers and laptops and cell phones and stuff like that. We think that's disrupting that pathway even more than the artificial lights from your ceiling, for example. But nonetheless, all right, here's a little bit more about how that works. So the light hits these cones, it goes through this pathway up to the suprachiasmatic nucleus, and then once it gets there, it interferes with the release of a chemical called melatonin. All right, so melatonin, and you probably have heard of us because we talked about this before, melatonin gets released ultimately from the pineal gland, right? And it is responsible sort of for helping with this cyclic process, this 24-hour biological rhythm of the night-day cycle. Right? So it's what's helping to influence these daily and seasonal, but mostly the daily biorhythms. Right? It's controlled by the suprachiasmatic nucleus. The suprachiasmatic nucleus of the hypothalamus ultimately will send messages to the pineal gland to either start producing, right, melatonin, or to stop producing melatonin. Right? So melatonin is made from the serotonin in the pineal gland. Right? Melatonin levels are then going to be either increased or decreased based on how much light you are getting. Right? So, when there is a bunch of light coming in, right, that's actually the signal, right, that your body will then get. Right? Your suprachiasmatic nucleus will go, whoa, must be daylight. Right? It will then signal to the pineal gland to say, okay, you need to stop making the melatonin. Right? So your body will then stop making the melatonin. That should make you feel less drowsy and more awake, and ultimately you will then wake up. Right? So melatonin levels drop as you get towards morning, and they should be fairly low throughout the day. Then as we get towards evening, especially as you anticipate going to bed, but definitely by the time it starts getting darker, right, your hypothalamus again, that suprachiasmatic nucleus, is going to start sending the message again back to the pineal gland saying, okay, it's about bedtime again. You need to start making a little more melatonin again. And so the body, the pineal gland specifically, will start cranking out the melatonin again. And that should cause at least most people to feel sleepy again. And again, if you get yourself on a rhythm, right, so if you go to bed at approximately the same time every night, which is one suggestion that you will be given if you ever go and try to get formal suggestions and formal advice from a doctor about how can I sleep better, that's one of the things that they'll say is get yourself on a pattern, get yourself on a rhythm, no matter what that is for you. If you need to go to bed at 9 o'clock every night, or if you need to go to bed at 1 o'clock every night, whatever it is, but if you get yourself on a pattern, right, what that allows your body to do is make this melatonin at a more reliable time. So it won't be making some here and some here and some here on different nights at different times. And the earlier you can get to bed and coordinate the melatonin release with the actual light dark outside, the even better response you will have because you'll produce more of it. Now again, I know that's not always realistic, right? Especially if you're like me and you have a job and you have to work late, or you have a kid and you have to stay up late sometimes, I get it. But again, the best you can, staying on a schedule is really good because you get the melatonin release when you want it, how you want it, at the right levels that you want it. This is also why for some people, melatonin supplements can help, but you would want to take them a little bit before you want to go to bed. So 30 minutes, an hour or so before you want to go to bed, so that it has time to get in. If it's going to work, it will have time to cross the blood-brain barrier and ultimately help you to have that feeling of sleepiness and relaxation. For some people, you can take them, but it's not actually going to be effective because your body's not going to absorb it in. So you can consume it, but it's not actually necessarily even going to have an effect. So again, that's why for some people it is not necessarily going to be ineffective. And you definitely would want to discuss it with your doctor, with your physician, before you actually started using melatonin as a sleep aid. But ultimately, your body makes it naturally, and there are some things that you can do to help it make more of it naturally. So if you are ready to go to bed, you're going to want to start off by trying to get yourself to relax and trying to get yourself to be in a darkened room, or at least a darker room, before you go to bed. So again, if you're laying in bed trying to relax and get sleepy and you use your phone and you're staring at your phone before you go to bed, you're not doing your brain any favors, because really you haven't quote unquote turned the light off, even if you've turned the overhead light off in your room, right? Because the light from your phone is still shining into your eyes, and so your brain is still not getting the signal to turn the melatonin on for the evening, if that makes any sense. All right, I'm going to stop there for this first part. That was what I was going to talk to you about just sort of the basic idea of biological rhythms. And again, I'm setting us up to talk about sleep. So that was the main one that I talked to you about. In the next lecture, we will specifically talk about sleep as a biological rhythm, as well as talking about sleep as an altered state of consciousness. And then in the final lecture for this section, we will talk about drugs as an altered state of consciousness as well. Talk to you soon.